when no current is drawn from cell. No current drawn from cell means when it is actually not connected or called as open circuit. So when no current is drawn from cell, that is when cell is open circuit, then potential difference between the terminal of cell is called as its electromotive force or EMF. Right, first definition. Can I clear this?
Yes.
I'm just showing you one basic circuit diagram with cell and resistance. This is symbolic representation of resistance connected to a cell. Longer is positive, shorter is negative. This is R. So when current flows from positive to negative, current is actually rate of flow of charge. This charge is opposed by resistance and also within the cell. That means see, this is positive. When current comes on the negative, now this positive will repel. That time battery will behave like pump, which will help that positive charge, that means current, to jump on the positive here. Now once it is jumped here, then it can move towards negative terminal. But again and again this pumping is required. So actually cell behaves like pump. In our building, on the ground we are having pumps or water storage. Then water comes here, gets stored. The watchman, with the help of pump, take his take it take that water to the storage at the top, and then it is going in different flow. So when this entire water is consumed, again he has to pump. So same way here, this battery is behaving like a pump. It gives the energy to the charge, it moves in the circuit, comes to positive, negative terminal. Now this positive will repel. Again it will give the energy. Again it will move. That energy is spent to circulate the charge. Suppose W is the energy spent to move the charge Q. Then energy is spent for unit charge, one charge, will become W by Q. This work done per unit charge to take the charge in complete circuit is called as EMF of cell. So I can say EMF of cell is defined as energy spent or work done per unit charge in taking the charge in complete circuit once, or you can say to taking the charge in the external circuit and within the electrolyte. It is one and the same. So now write or the EMF of cell or the EMF of cell is defined as EMF is defined as amount of work done per unit charge amount of work done per unit charge in taking positive test charge in taking positive test charge in complete circuit once. In complete circuit once. If W is the work done in taking test charge Q around complete circuit of the cell, then EMF of the cell is given by, so this symbol is also called as epsilon. Just like E, it is called epsilon. Is W upon Q. Its SI unit is joule upon coulomb or volts. Its SI unit is joule per coulomb or volts. Completed?
Yes, sir.
Right. State the factors on which EMF depends. State the factors on which EMF depends. EMF of a cell depends. The EMF of a cell depends on, first, the material of electrodes. The material of electrodes. Second, the electrolyte used in the cell. Electrolyte used in the cell. The meaning of this, if material of electrodes gets ionized fast, that means releases the electron fast, it will be more positively charged. Same way electrolyte helps in dissociation. That means if we have sulfuric acid, it dissociates fast. Positive will go to one electrode, takes electron from there, becomes neutral. So the speed at which it can release the electron gives the EMF of cell. That depends upon how electrolyte is getting dissociated. So that's why the material and electrolyte used in the cell. It is independent of, this is also very important. It is independent of the shape of electrode. It depends upon material, not the shape. So it is independent of the shape of electrodes. B, the distance between the electrodes. C, the amount of electrolyte in the cell. Thus, EMF of a cell is its characteristics property. Characteristics property. It is different for different type of cell. It is different for different kinds of cells. Example, the EMF of a voltaic cell is 1.08 volt. For Leclanche cell, EMF is 1.5 volt, and for Daniell cell, it is same as voltaic cell. Actually voltaic cell Daniell cell same होता है, ये खाली glass का रहता है, और Daniell cell it is not of glass, not made up of glass. So with this we got rough idea. It is EMF is nothing but actually energy required to send the charge in complete circuit once. Shall I clear this?
Yes.
Terminal voltage. One was EMF, now it is terminal voltage of a cell. The terminal means end to end. Like if this is a container containing electrolyte such as dilute sulfuric acid, in which two electrode, copper and zinc are immersed. Copper and zinc are immersed. If this is connected to the resistance externally, then current flows from copper, which is behaving like positive terminal, to the negative terminal. Its circuit diagram you can represent as shown. Potential difference or terminal voltage is work done to move the charge, per unit charge through the external resistance. The EMF was complete circuit. This is only through external resistance. So when current is drawn from cell, that is when the circuit is closed, the potential difference between the electrodes of cell, or we can say indirectly between the across the resistance, is called as terminal potential difference. So open circuit wala voltage was EMF, closed circuit wala voltage across the terminal is called as terminal potential difference. It is usually denoted as V. This is EMF E, and iska across ka voltage is denoted by V. Please draw this diagram, then we'll write the explanation. When current is drawn from a cell, that is when the cell is in closed circuit. When current is drawn from the cell, that is when cell is in closed circuit. Then the potential difference between the electrodes of the cell is known as its terminal voltage. Is known as its terminal voltage. When current is drawn from a cell, that is when cell is in closed circuit, then potential difference between the electrodes of the cell is known as its terminal voltage. I'm just removing this. Thus, if W is the work done, if W is the work done to move test charge Q across terminals of cell, then terminal voltage of cell comma V equals to W upon Q. Its SI unit is joule per coulomb or volts. Is completed now? Now imagine this is cell. This is resistance. This is total 10 volt. Here we get 8 volt. So 2 volt must be इसका अंदर ना, ये cell के अंदर. 10 was total. 8 is in outside. So remaining 2 is where? Inside na? Hello? Hello?
Yes, sir.
So this work done per unit charge to move the charge through the electrolyte, through this electrolyte here. This is called actually voltage drop in the cell or voltage across internal resistance. So always you will see that terminal voltage is less than total EMF because total voltage is E is given to external plus internal. So if they ask what is voltage drop in the cell, so work done to move unit positive charge within the electrolyte is called as voltage drop in the cell. Right, define voltage drop in the cell. The amount of work done to move unit positive charge through the electrolyte, unit positive charge through the electrolyte is called as voltage drop in the cell. It's called as voltage drop in the cell. Obtain relation between EMF and terminal voltage of a cell. Obtain relation between EMF and terminal voltage of a cell. See. Consider charge Q to be moved in complete circuit. Let W, comma W dash, comma small w be the work done to move the charge Q in complete circuit, comma across the terminal of the cell and through the electrolyte respectively. Through the electrolyte respectively. So we can say total work done is utilized for terminal difference plus small w is for internal. Dividing throughout by Q, it becomes W upon Q equals to W dash upon Q, small w upon Q. But total work done to move the charge is called as EMF. In terminal, it is called potential difference across the terminal or terminal voltage. This is internal voltage. Just copy till this, and 3 more lines we have to write. Is done.
Yes, sir.
But W upon Q equals to E equals to EMF of cell, and W dash upon Q is E, which is called terminal potential difference, or voltage, one in the same, and small w upon q is small v, voltage drop in cell. So I can say therefore EMF is terminal voltage plus voltage drop in the cell. Yeah, just copy now 4 lines. Completed?
Yes, sir.
Okay. So from this you can say V equals to E minus voltage drop in the cell. Therefore we can say terminal voltage is less than EMF because it is E minus that, it is less than EMF. If voltage drop in cell increases, then terminal voltage will decrease. When terminal voltage decreases. Thus, terminal voltage depends on the amount of current drawn. Because more the current drawn, more charge will flow through electrolyte, more voltage will be dropped inside. Yes, I'm just clearing this now. Internal resistance of a cell. Internal means inside. So when the charges are moving within the electrolyte, they collide among themselves. This collision opposes the motion and give rise to the resistance. So the resistance offered, by the electrolyte, the resistance offered by the electrolyte inside the cell to the flow of current is called as internal resistance. Resistance offered to the flow offered by the electrolyte inside the cell to the flow of current is called as internal resistance. It is denoted by small r. Its SI unit is ohms, denoted by omega. Therefore, voltage drop in the cell, comma, small v equals to I into small r. Yes, written this also, internal resistance.
Yes, sir.
Okay. Symbolic representation of cell with internal resistance. So always internal resistance is shown with the cell. This is internal resistance, small r, and this is EMF of the cell. This together is actually called cell. Internal resistance with this two electrode is called as EMF of cell. Mostly connected on the negative side of the EMF. Right heading and draw diagram. Did it?
Yes, sir.
Very, very important relationship between the EMF, comma, terminal voltage and internal resistance. Relationship between EMF, terminal voltage and internal resistance. Suppose this is a cell of EMF E Generally, it is right. I'm telling you, but it is written as epsilon R connected to the external resistance capital R. So this entire combination is actually cell. Current flows from positive, enters in negative. Let V is voltage across internal resistance, external resistance R. Consider a cell of EMF epsilon and current and internal resistance small r connected to an external resistance capital R to supply current capital I. Therefore, I equals to, I means total current, is EMF of cell upon total resistance. So we can say I equals to this epsilon into R plus R. Yes, just draw the diagram and write till this. Total current is total voltage, which is E upon total resistance capital R plus small r. Is completed. Completed till I equals to E upon R plus R. Okay. Shall I clear it? Hello?
Yes, sir.
So we got I equals to E upon R plus R. So from this you can say E, actually it is epsilon, I am writing as E, it is easier to manage. So it is I into capital R plus small r. Therefore E will become I into R plus I into small r. This is equals to capital V plus small v. So therefore I can say E minus V equal to small v. So E minus V, this is I into small r. So internal resistance if you have to find, then small v upon I, or difference of potential of EMF and terminal divided by I. Or, so don't remember in exam so many things. This is sufficient enough. When it is required, we'll arrange. But if they say show that small r is E minus V upon I, then you proceed. So from this, if I divide, this is E minus V, I is V upon R. So R is also E minus V upon V into R. So we can also write this internal resistance R as E upon V minus 1 into capital R. So sometimes they can ask which one is the correct option for internal resistance. So it is E minus V upon I. I you can write V by R. And then when you rearrange this I V by R goes up. E upon V minus V upon V, that is E upon V minus 1 into R. Only they can ask show that. So you have to remember this sequence. Total voltage is total current, total resistance. I into external terminal voltage. I into internal voltage in the cell. So E minus V voltage in the cell, which is E minus V is IR. So R is E minus V upon I, or internal voltage upon I. Or we can write E minus V by V into R, which is E upon V minus 1 into R. Write down, they can ask if the paper is difficult, which one is correct formula for R. So can I clear this?
Yes, sir.
Right. Factors affecting the internal resistance of cell. Factors affecting internal resistance of cell. The internal resistance of cell depends upon following factors. First, the surface area of the electrodes depends upon surface area of electrodes. Larger the surface area, larger the surface area of electrodes, less is the internal resistance. Larger the surface area, smaller the internal resistance. Second, the distance between the electrodes. The distance between the electrodes. Internal resistance increases with the distance between electrodes. Internal resistance increases with the distance between electrodes. So, the nature and concentration of the electrolyte. The nature and concentration of the electrolyte. Less ionic. Less ionic means less ions are released. Less ionic the electrolyte or higher concentration, less ionic the electrolyte or higher concentration of electrolyte. Higher concentration, then greater is the internal resistance. Higher concentration, greater is the internal resistance. Fourth one, the temperature of the electrolyte. Increase in temperature decreases the internal resistance. Increase in temperature decreases the internal resistance. Yes, can I clear this?
Yes.
Then write resistance in series. When same current flows through each resistances, then it is called as series combination of resistance. When same current flows through each resistances, then it is called as series combination of resistance. In series, RS, that means equivalent resistance, RS equals to R1 plus R2 up to last resistance. This also done. Resistance in parallel. When current gets divided, but potential remains same, then combination is called as parallel combination of resistors. Now see, what does it mean? If this is one resistance, another resistance, third, one below another connected. Current comes here, it will get divided into three parts. I1, I2, I3. But these 2 points are same. So voltage between I1, I2, I3 is same. But current gets divided. That combination is called parallel combination. If Rp is equivalent in parallel, then 1 upon Rp is 1 upon R1 plus 1 upon R2 dot 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 up to 1 upon Rn. 1 upon R1 plus 1 upon R2 up to 1 upon Rn. So remember, always in parallel voltage is same, in series current is same. Completed? Hello?
Yes, sir.
Two resistances are in parallel, show that Rp equals to product upon sum. So that Rp equals to product upon sum. Since 1 upon Rp equal to 1 upon R1 plus 1 upon R2. So 1 upon Rp is R2 plus R1 upon R1 R2. So Rp equals to product upon sum. Hence proved. Copy first one. Then two equal resistances are in parallel, then Rp equals to R upon 2. Second also write down, when two equal resistance are in parallel, then Rp equals to R by 2. One upon Rp equals to 1 upon R1 plus 1 upon R2. So this is 1 upon R plus 1 upon R equals to 2 upon R. Rp equals to R by 2. See, if N equal resistances are in parallel, then Rp equals to R upon N. So 2 equal in parallel, R by 2. 3 equal in parallel, you will get R by 3. 4 equal in parallel, R by 4. N equal in parallel, R by N. One upon Rp equal to 1 upon R1 plus 1 upon R2 up to Rn. So 1 upon Rp is 1 upon R plus 1 upon r up to 1 upon r, total n. So this will become 1 plus 1 plus 1 n times n by r. Take reciprocal, rp equal to r by n. Now entire theory is completed of part 1. Part A and B, numerical is left out. Part C is deleted from the syllabus. Is completed? Hello?
Yes, sir.
So today you all have, what you have in the college school today?
We have a workshop.
Workshop, that is 5:55.
Yeah, so it will start at 6. So we have to log in like 5-10 minutes early.
Now your exam is actually on starting from 9th of 11, 9/11, na?
Yeah.
So one more week we have, I will complete this numerical. Then in between you have holiday also, 2011 to 23 November. So we get one more day. So okay, please revise. This Sunday you will write test on part A and B of current. Hello? Hello?